What if I told you that a simple seaweed-based coating could keep your strawberries fresh for days without needing a fridge? Imagine walking into a grocery store and seeing perfectly ripe fruit on shelves that don't require energy-guzzling cold storage. That's exactly what University of British Columbia researchers are cooking up, and it's blowing my mind. Let me break down why this feels like a seismic shift in how we think about food preservation. Here's the thing, 25% of all fruits and veggies get tossed before they even reach your plate. That's not just wasteful, it's a global crisis. Now picture a world where strawberries, grapes, and apples stay crisp and juicy without needing to be shipped in climate-controlled trucks. That's the promise of this agar-based coating, and it's not just about convenience. It's about rethinking the entire supply chain. Think about the energy savings alone. If we could slash refrigeration needs, we'd be talking about millions of tons of carbon emissions avoided every year. But here's the kicker, this isn't just another eco-friendly gimmick. It's a fundamentally different approach to food preservation, one that's rooted in nature's own chemistry. Let me unpack what's actually happening here. The team took agar, a substance you've probably seen in desserts, and mixed it with zinc and tannic acid, which is in tea and grapes. The magic? These ingredients self-assemble into a microscopic armor that clings to fruit. It's like giving strawberries a second skin, but way cooler. What's fascinating is how this layer works. It locks in moisture, fights mold, and even retains nutrients. I mean, how do you even begin to wrap your head around the fact that this stuff could extend shelf life by 400%? It's not just about keeping fruit from rotting, it's about preserving the very essence of what makes produce nutritious and delicious. But here's where it gets really wild. This isn't a one-trick pony. The same coating worked on grapes for 2 weeks and apple slices for a day. That versatility opens up a whole new world of possibilities. Could we one day see this used on tropical fruits that currently require massive refrigeration costs to ship? Or maybe even on vegetables that wilt in hours? The implications for food distribution in developing countries are staggering. Imagine a farmer in a remote village packing fruit that doesn't need a fridge to survive the journey to market. That's not just innovation, it's a revolution. Of course, there are hurdles. Regulatory approval, scaling production, and convincing consumers to trust an invisible coating on their food. That's going to take work. And let's be honest, there's still a lot we don't know. Will this hold up under extreme conditions? How does it perform with different fruit varieties? But here's what excites me. This isn't just about solving one problem. It's about creating a blueprint for sustainable food systems. If this technology takes off, it could disrupt everything from packaging, goodbye, single-use plastics, to energy consumption in logistics. And let's not forget the environmental win. A 14% lower carbon footprint compared to refrigeration. That's not just a number, it's a glimpse of what's possible when we stop trying to fight nature and start working with it. So the next time you see a strawberry, think about the invisible science protecting it. This isn't just about keeping fruit fresh, it's about reimagining how we feed the world. And honestly, I can't wait to see where this goes.